Okay, have you completed this part? We'll see the variable volume batch reactor. The second part that we have to consider is a variable volume batch reactor. So earlier what we have considered, the volume of reactor was a constant. So it was not contributing in the rate reaction. Obviously their mechanism we have to consider is a rate. Interested in the calculation of rate of reaction minus RE. So here it was a volume we have kept constant. So obviously because of the rate of reaction, all the factors are going to be contributing, the rate of reaction is going to change. What are the different factors? Obviously Na, P, then concentration, these factors are going to be contributing the rate of reaction. So if you are going to consider variable volume, then during reaction, the volume of that reactor is going to change. Earlier, in a constant volume batch reactor, we have considered volume as a constant. So because of that, rate is equal to 1 upon V dNA by dt, or also we have considered minus dCA by dt when this volume we have kept as a constant, or rather it was constant during reaction. So if you consider this particular rate equation, this V is going to contribute in the rate equation. But now in the variable volume batch reactor, the volume is going to change. It is a fractional that we have to consider by considering the factor called epsilon. That is a fractional change in volume in the full conversion to the initial conversion. So what would be the volume? So this is a fractional change in volume that we have to consider. That would be volume at x is equal to 1 minus volume x is equal to 0 minus volume x is equal to 0. On A, we have considered for the A reactant. So for the reactant A, the volume, what is the volume at the full conversion minus volume at initial divided by initial volume. So that factor would give the fractional change in volume. Fractional change in volume. So this is the most important concept in a variable volume batch reactor. We need to calculate this epsilon value. We need to calculate epsilon value. If you are going to consider simple reactor, there this is a simple reactor where this reaction, if you are going to consider, might be most of the time volume remains constant, but some other time where we have to measure the volume. For that purpose, we have to consider simple bead. There is would be a simple tank reactor where a simple bead would be kept, and this would be the reaction volume that is going to change with respect to time. This is a bead we can consider. Suppose this is a x is equal to 0 and this would be the x is equal to 1. What that? This is a volume. Volume at initially when conversion is not happening, and volume at full conversion. So this is a full volume, or rather volume is going to be calculated at the final stage, means when reaction is completed, and this is a initial volume. There are some, most of the reactions are there, this because of that specific reaction nature, the volume of that reaction mixture is going to change. Generally whatever we have seen earlier, here we have considered constant volume of that particular reactor system. Volume was kept constant. So because of that, simply the V was constant. So Na by V, what considered as a Ca. So minus Ra was dCA by dt. But now this volume is going to change. It is going to impact in the concentration. Because of that, rate is going to vary. This is for the constant volume. Now we are considering the variable volume batch reactor. So how we are going to calculate this epsilon value, or the fractional change in volume, that by the volume at the final stage minus volume at the initial divided by volume at initial condition. So generally what happen, volume it is not so easy to measure. It would be measured in terms of number of molecules taking part in the reaction. What would be the initial molecules or moles available in the reaction to the final moles available in the reactor system. Suppose A plus B, I am taking example, A plus B giving single molecule AB, or it is going to give a 4 molecules of AB. Suppose this is, for example, I am taking example. So now epsilon would be calculated for this particular reaction, would be calculated by in terms of molecules present in the system. What would be the molecules present at the end of the reaction? That would be the 4 molecules. So we can consider volume as a 4. And what would be the initial moles? 1 plus 1. That would be 2. So epsilon would be calculated 4 minus 2 divided by 2. So it would be 2 divided by 2. Epsilon factor comes as a 1. Now there is a one relation. By using this relation, we are going to calculate a volume. This is a fractional change in volume. By using this particular exam, number of moles present at the product level to the number of moles at the reactant level, we can calculate epsilon value. Simple stage, simple thing we can calculate. Is it okay? So now we can consider this particular fractional change in volume in terms of volume as the second expression, P is equal to P naught 1 plus epsilon A into Xa. This would be called as the initial volume. That is going to change as a final volume. This is a fractional change in value. This is a fractional conversion that we know. So we can simplify this expression as a V is equal to V naught plus V naught into epsilon A into Xa. So this particular initial volume is changed by V naught into epsilon A into Xa. So in terms of initial volume, this particular fractional change in volume is going to occur, and that would be added in the system, and this would be the final volume we are going to calculate. So for the variable volume batch reactor, we have to know these two expressions. One is epsilon and another would be the most important, how we are going to calculate this volume. V would be equal to V naught into 1 plus epsilon A into X. This we need to by hand. These two expressions. These are the two most expressions. In this part, how we have calculated this particular volume. For these two expression, any doubt? Epsilon value, fractional change in volume, this particular part, that would be added into the initial volume so that we can get the final volume. Now if you consider, we have two expressions now. Epsilon A, that would be a volume at x is equal to 1 minus volume at x is equal to 0 divided by x is equal to 0. Means it would be calculated fractional change in volume. So that fractional change in volume would be utilized for the calculation of final volume. That formula would be P is equal to V naught 1 plus epsilon A into XA. So because of these two expression, we are interested in the calculation of CA value. How we can calculate the CA value? I think there would not be any doubt regarding these two expressions. Have you any doubt? For the variable volume batch reactor, we have to know these two expressions. The two expressions, fraction change in volume and how V would be calculated. V is a volume of a batch reactor. Obviously, this volume is going to vary, and this would be the final volume. So what would be CA? CA would be Na by V. It would be